Today I'm going to give you a brief tutorial on how to name and write formulas for ionic compounds, molecular compounds, and acids. So we'll start with ionic compounds. They are made up of a cation and an anion. A cation comes from a metal that will lose one or more valence electrons. A nonmetal will gain one or more electrons to become an anion with a negative charge. For example, sodium is a metal. It has one valence electron, so when it becomes an ion, it loses that electron and has a +1 charge. Chlorine is a nonmetal. It has 7 valence electrons. It wants 8, just like everything else, so it gains an electron to have a -1 charge. When you're naming ionic compounds, the name of the cation is the same as the element. The name of the anion changes its ending to IDE. So for a compound like AlBr3, we would name it aluminum bromide, changing that ending to IDE. If the cation is a transition metals can have more than one positive charge, and that charge must be represented with a Roman numeral, and we can figure out the charge by using the charge of the anion. So, for example, PbO2, we are going to name lead, some Roman numeral that represents the charge, oxide. Now to figure out the Roman numeral, we look at the charge of oxide. Oxide has a charge of -2. There are 2 oxides, so that's a grand total of -4. That means lead has to be +4 to cancel out the -4, making our Roman numeral 4. So the name of the compound is lead 4 oxide. If you have an anion that's a polyatomic ion, you just use the name of the polyatomic ion. NaNO3 would be named sodium nitrate. NO3 is named nitrate, and that's something that you need to memorize. Now, if we want to go the other way, if we know the name but we want to write the formula, we have to know the charge of each ion and then make sure they add up to 0 so that the compound is neutral. So for magnesium chloride, we would look at the periodic table and figure out that magnesium has a +2 charge. Chloride has a -1 charge. So to make their charges add up to 0, we have to have 2 chlorides. So the compound is MgCl2. For lithium phosphate, lithium will have a charge of +1. Phosphate is a polyatomic ion. It's PO4 with a -3 charge. So we're going to need 3 lithium ions. So we write Li3PO4. For aluminum hydroxide, aluminum will have a charge of +3. Hydroxide is a polyatomic ion with a charge of -1. When you need more than one polyatomic ion like we do here, you have to write it in parentheses. So we have to put our hydroxide in parentheses and then show that we need 3 hydroxides. Now, if you have a molecular compounds are made of 2 or more nonmetals sharing their valence electrons, and there aren't any ionic charges in these, so you have to use the prefixes to show how many of each atom are in the compound. And these are the prefixes for 1 through 10. So mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa 8, nona 9, and deca 10. And you need to know those prefixes. So when you're naming a molecular compound, you name the first element with a prefix, except if there's only one. We don't use mono on the first element. Then we name the second element with a prefix and change the ending to "ide." So a compound like SO2, we would name sulfur dioxide to show that there's 1 sulfur and 2 oxygens in that compound. And writing the formulas are very easy because the prefix tells you how many of each element are in the compound. So carbon tetrachloride means there's 1 carbon and 4 chlorines. And it's that simple. Now, if you have an acid, acids are going to be ionic compounds where hydrogen is the cation. So rather than having a metal, it has hydrogen as that cation. And the name of the acid comes from the anion's name. So if your anion ends with "ide," then the acid will be named hydro, whatever the element is, ic acid. If your anion ends with "ate," it will become ic acid. And if your anion ends with "ite," we change the "ite" to "us." For example, HF. F is the fluoride ion, so we change that "ide" and make this hydrofluoric acid. NO3 is nitrate, so we change the "ate" to "ic" and make it nitric acid. SO3 is sulfite, so we change the "ite" to "us." Now, if you have a polyatomic with sulfur or phosphorus in it, you have to add in an extra syllable. So sulfite becomes sulfurous acid. And then if you want to go the other way, you have to look at the ending to know what the anion is that's attached to hydrogen. So in carbonic acid, we know it's an acid, so our cation is hydrogen. And then the ic tells us that the carbonate ion is attached to the hydrogen. And carbonate is CO3 negative 2. So carbonic acid is H2CO3. We balance those charges just like we did before. Hydrobromic acid has bromide as the anion, and bromide is Br negative 1, so hydrobromic acid is HBr. Nitrous acid has nitrite as the anion, and nitrite is NO2 negative 1, so nitrous acid is HNO2.